my audio is good. My stream is good. Hello, hello. Yeah, it's good. It's good. Let's continue.
Up to this point, we've covered some important topics for software engineering in Python. Now we're going to get our hands dirty and put these ideas into practice by building a Python package from the ground up. We've seen how useful packages can be for easily importing functionality into a workflow. But what is under the covers? How do we make one ourselves? A minimal Python package consists of two elements, a directory and a Python file. You can see the basic structure here. The name of the directory will be the name of the package, but how should you name it? We can turn to PEP8 for some guidance. To paraphrase, PEP8 states that packages should have short, all lowercase names. The use of underscores in a package name is discouraged, but you can and should use them if it improves readability. Outside of this, you have the freedom to brand as you'd like. I'd suggest picking a name that conveys the functionality of the package. The file in our newly branded directory doesn't have any flexibility in naming. We must name it __init__.py. This file lets Python know that the directory we created is a package, and that's it. With this structure, we've created a package that we can import just like we would import NumPy or any other package. Note that as of Python version 3.3, any directory can be imported as if it were a package without error, even if it doesn't follow this structure. Earlier versions of Python would throw an error if you tried to import an improperly formatted package. Even though a directory might import without error, you will run into issues if you do not follow this structure. So how do we import our package? Before we look at some code, let's establish where our script is relative to our new package. We'll be working in the myscript.py file that's in the same location as our package directory. With all the setup we've done so far, importing the package is a breeze. At the top of our script, we can use the same location as our package directory. With all the setup we've done so far, importing the package is a breeze. At the top of our script, we can use import my package. Just for an added bonus, let's check out what happens if we try to call help on our package. We get some minimal information with Python letting us know that it is indeed a package, and additionally, we see the location of our init.py file. As we previously covered, it's up to the developer to add in useful documentation to be printed whenever a user calls help. Later, we will be going over how we can add this documentation as well as implementing some functionality to make our package more useful. We just covered how to make a Python package skeleton. This is an important concept that will serve as a foundation for all the useful packages you'll be writing in the future. Before that, let's review with some exercises.
Sure. So what are the minimum requirements to make an importable package? Add a directory. Name init? No, a directory with a blank file name in it. Yeah, this one. Okay, now we cover PEP8 guidelines for naming packages. In this exercise, you will use that knowledge to identify a package following the requirements. So I'm gonna so the one that follows is only this one, text analyzer, because it needs to be all lowercase. With each word, it should be concatenated with the other one with a underscore. Yeah. All right. So a script. Use the information for the file structure. So that follow the minimum package requirements. So my package knows because it's uppercase. This one, it's okay. This is a folder, so it's not correct. This is okay. Help package and help by package. All right. Adding functionality to
Great work on those exercises. You're now a bona fide Python package developer. The next step to package development is to add some useful functionality. To start, let's again look at the file structure we'll be using. Here we've added a file to our packages directory named utils.py. Again, when we import and work with our resulting package, we'll be in the myscript file that's in the same directory as our package. Note that we can choose a different name than utils, but keep in mind that file names should follow the same conventions as package naming. That is, file names should be all lowercase and avoid underscores unless it improves readability or if it's a special case such as our packages init file. With the right structure in place, the next step is to write some code. Here, in our utils.py file, we write a function that prints one of two possible statements based on user input. Our utils file is known as a submodule, and we can import it with a dot notation syntax of the form package name dot submodule name dot function name. In this example, we call mypackage.utils.we-need-to-talk. Alternatively, we can use our packages init file to make our utils functions more easily accessible by the user. To do this, we import our function in our init file as you see here.
I kind of disconcentrated. Okay. So inside of the package in the utils, so I can import my package.utils, which is the submodel there. And then from there we can import a function we need to talk. Okay, through. Okay.
Our utils functions more easily accessible by the user. To do this, we import our function in our init file as you see here. The dot notation we use when writing .utils is known as a relative import, and it must be used when packaging in Python versions 3 and above. Importing our function in the init file saves some typing when we want to import and use our function. We're now able to call mypackage.we-need-to-talk without including the additional reference to our utils submodule. Importing the function in the init file took care of this reference for us. In our example, we added a single file or submodule to our package, but we can extend this structure indefinitely to meet our needs. However, when creating larger packages, you must be more mindful about organization. When working with multiple submodules, should you import them all in init? As a general rule, you should import your package's key functionality in your init file to make it directly and easily accessible. Less central functionality can be accessed by users through the longer submodule syntax we saw earlier. The decision of what is key functionality is a gray area, and because of this, there isn't always a clear best way to organize your package. As a package developer, you'll need to use your judgment to decide what you think will give your users the best experience. In addition to adding additional submodules, you can also build out packages inside your package. These are known as subpackages. Okay. Notice how the subpackage still follows the packaging rules of being a directory with an init file. We won't be covering subpackages in depth in this course, but exposure to these different structures can be helpful when looking at someone else's code. Alright, we just covered how to add functionality by defining functions in a package by using submodules and the init file. In the following exercises, you'll practice this important skill. Good luck!
Okay, so adding functionality to your package. So for the front counter, you'll be you will work to define the functionality needed for text analysis of work usage. In the file counter utils, define the functions to be part of your package. Okay. So this is called counter utils. Okay. Let's get some help because I don't know what's going on. because the counter was already imported from here. Okay, return the correct sum counters. So I get this here. So the function is focused in the file counter utils. Yeah, so from counter utils import. For the relative import. So you were inside on the index.py. Okay. So from the text analyzer, import some counters and from text analyzer, and here some counters okay, so let's do like this, text analyzer, and then I'll use the function some counters, and the same do with text analyzer, and this will be load counter. Then it will plot like this. All right.
Now that you have a functional package, you might want to share it with your colleagues. The two main steps to sharing a Python package are creating setup.py and requirements.txt. These two pieces provide information on how to install your package and recreate its required environment. These files list information about what dependencies you've used, as well as allowing you to describe your package with additional metadata. Here's how the two files fit into our package structure. They're located at the same level as our package directory.
Wait. Just for the sake of yes, just for the sake of doing this also here, we're gonna create the text analyzer. In here we're gonna have the init. In here we're gonna have the counter utils. Then in here we are going to have the well, I already passed this, so I'm just gonna do this. In file it will be 5 using script using package created package, and in here I'm gonna do this, which is gonna import the spy. Let's import the text analyzer. In the init we should import this. float counter and some counters. Then now in here, in the first one, this is inside of the counter utils. In here we need to do the sum counters. So in here I initialize in here I import the float counter and the sum counters, and in this one 5 force count. So basically what I'm doing here is something like this. So we get the so that this file. Because I mean, regarding the imports, I got it. You define here, then you import from the relative file these ones. So these ones I can already just do in the number 5 import text analyzer, and I can just import the functions defined in this counter utils. But I want to know like what what is this file wanted to do in reality. Because in this sum counters, what it's doing is so that's why I couldn't understand. So here I have the counter, so it's like a count of words here, and there's like 3 different counters. So what I'm doing here in this file, it's passing the counters because there is an array of like tuples of, if I do here print counters and I do Python, not here but Python 5 sorry I didn't I need to close this stuff. Okay. Splitting. So here's a counter with each word and its count, and here's another counter. So basically when I do this sum, I sum the counters. So now I have an unique amount of counters here. So this is the totals, which will be print word count totals, which will not give me an array, but will give me an will give me a single counter object now, because now I have an array of counters. So if I just close here and I do this, and here's print. Now will be the total, because in the first, as you see there, there's like 1, 2 da in the first counter, but now it's a single counter object. It's like now in the whole string there is 6, fox 3, quick 2. So now then with that we can do the word counts total, so to plot, which was something that we were doing. No, here we were just printing. So plot counter word town scuttle. Okay. And then we go here, plot counter, the most common, which is this, the most common top item. So it's just gonna return the top ones. Here's the function to plot, which is here going to be tuples. So I'm just gonna have words and counts. What this does, because I don't know why does that zip with the asterisk is doing there. So it's an array of tuples, yeah? No, I mean, yeah, it's gonna return to first. So, but why the asterisk? Uh-huh. All right, all right. Each argument, because its own separate argument to zip. Okay, so I need to pass a list of arguments there. So it's something that I need to remember the whole time. All right. So let's go to the. Okay, making your package portable.
Now that you have a functional package, you might want to share it with your colleagues. The two main steps to sharing a Python package are creating setup.py and requirements.txt. These two pieces provide information on how to install your package and recreate its required environment. These files list information about what dependencies you've used, as well as allowing you to describe your package with additional metadata. Here's how the two files fit into our package structure. They're located at the same level as our package directory. Now let's see what content goes into the files themselves. A requirements file shows how to recreate the environment needed to properly use your package. This includes a list of Python packages to recreate the environment needed files themselves. Now let's see what content goes into the files themselves. A requirements file shows how to recreate the environment needed to properly use your package. This includes a list of Python packages and optionally the version requirements for each package. Here we see 3 different ways to specify our requirements. If we don't have a reason to specify a version, we can just list the package name as you see here for matplotlib. If version is important, we can mark a specific version by using a double equals, or mark a minimum version by using greater than or equal. Since open source packages are constantly evolving, specifying a version can be a big help to your users. To leverage our requirements file, we can use this pip install command. This installs all the packages listed with respect to the correct version. Note that we didn't actually install our package, we just recreated its environment. Setup.py is what tells pip how to install our actual package. Additionally, its info will be used by PyPy if you decide to publish. The contents of this, in our case, contains a single call to the setup function from the setup tools package. There are other options, but setup tools is one of the most common and powerful choices. Here we use just a few of the possible setup arguments. There are many more options available that you can read more about in the setup tools documentation. The arguments' names make them fairly self-explanatory. For example, your package's name is assigned to name, and so on. Some less obvious arguments in our example are install requires and packages. Packages, in essence, list the location of all the init files in our package. Our package has a single init file, and it's in the directory my package. As we saw before, more complex packages might include subpackages with their own init files. If this was the case, we would also list their locations here. Until you start writing more complex packages, the contents of the packages list will likely be the same as the name argument. Install requires might look familiar. In the case of our package, the contents are the same as our requirements file. An example of when install requires can differ is if you want to specify where pip should download packages from. This can be specified in the requirements file as you see here. We won't go into much detail here since this advanced option is not often needed in everyday use. To read up more on the differences, you can see the documentation linked here. Now that we've completed our setup.py, we can install our package with pip using pip install dot from inside the same directory as our package. This will install our package at an environment level so we can import it into any Python script using the same environment. We just covered some important aspects of how to make your package portable. Let's jump into some exercises to review.
Let's do it. And then let's go to gym, bros. I'm too tired. Write the requirements for matplotlib. So it's gonna be 3.0.0. NumPy is gonna be. It's kind of this. Let's just call it boring. I already know a lot of things. From here, pandas equals to. With at least a version of this, so I need to do major exactly. With at most, this will be my NumPy code style, just like that. Okay. So this is majors equals. Okay. Requirements.text. And the work there. Which recreate my package for requirements. I think it will be this setup. No? To install the related package itself. No, it's environment. So I need to do this. Wait, what? It's an error to specify your time. pip install -r. Okay, let's explain me the difference between without. Okay, here in the from from setup tools, import setup, directory text analyzer. So I am Luis, the name, so this allows me to make my packages installable by pip. If I don't have this set up, I will not be able to install my packages with pip. Let's just do this. So this is going to be the setup. Here we're gonna put the so R means read package's name from this file. Pip installs each listed package state from PyPy or in this computer. Okay. Okay, so let's do something. Explain the difference between these commands. So if I do this, it's incorrect because I need to read the files, not the file. If so, in here I mentioned some. If I don't put this, here is gonna try to pull something from the cloud, from the pip packages. So here is missing the txt. So here is installing the file from the requirement, but from the correct file. So but this setup by defines my package for distribution. So I need to do this to define this package, but to distribute in the pip. Okay, I got it. So this one I already did. Okay, and now listen requirements in setup. So from here we import setup tools. In the text analyzer, the author is Luis. And in here we define what it requires, which is matplotlib. So bigger or equal to 3.0.0. All right. Okay, guys, I'm going to gym at the moment. So let's see each other in a while.